In problem 8, we need to use exponent rules to simplify these expressions. And we want our final answers to only include positive exponents. So we also want to simplify negative exponents. So one of the big things to understand about working with exponents is when can we add exponents together or subtract them versus when can we multiply exponents. One of the key things to notice is that if the base is repeated, that's the situation when we can add the exponents. So I have the same base for part A, the base is 2, and so I can add these exponents together. So I end up with 2 to the 4n minus 1. Now in part B we have something a little different going on. I have an expression in the parentheses here that is being raised to a power, but that expression involves exponents already, x to the 4th and y squared. So I can do two things. I can distribute this exponent to the two factors inside the expression, but when I do that, I'm going to multiply the exponents together. So this becomes negative 5 x cubed times y. Let me just repeat that. And then x to the 8th power times y to the 4th. And now we're in a situation similar to what we had in part A, where we have some exponential expressions multiplied together. The base is repeated. We see x twice and we see y twice. And so I can add those exponents. But one thing before I do, let me point out that y here without an exponent, I can think of this as y to the 1st power. So if I add together the x factors, I get x to the 11. And then similarly, adding the exponents of the y factors, I get y to the 5th. And that's my final answer. Part C is, again, somewhat similar. I have an expression in parentheses raised to a power. So I can distribute that exponent to each of the factors, and there are 4 of them. So let me do that first. I have 5 to the negative 2nd times a to the negative 2nd. And now I'm going to multiply b to the positive 6th and c to the 8th, the negative 8th. But we want our answer to only have positive exponents in it. And so anything with a negative exponent I can rewrite with a positive exponent if I create a denominator. So b to the 6th has a positive exponent, so that will stay up in my numerator. In the denominator I get 5 squared. By changing the negative exponent to a positive, I can rewrite that in the denominator. A squared and c to the positive 8. And let me just simplify this one bit more. 5 squared is a perfectly fine way to write that number, but it's a pretty small number if we actually multiply it out. So let me write that as 25. A squared c to the 8th. 25 in the denominator. And that's our result. b to the 6th over 25 times a squared c to the 8th power. And now the last part of problem 8, part D, has a couple things going on. The first thing I'm going to point out is that we have z to the 0 power. Anything raised to the 0 power is automatically equal to 1. And so that actually sort of disappears from our expression because it just becomes 1 times 2x cubed. We see x a couple times, x to the 3rd power and x to the 5th. And we can treat these in a couple ways. I can subtract those exponents. So one way that I could think about this would be x cubed, just that part of the expression over x to the 5th. I could write this as x to the negative 2nd, but I don't want negative exponents. So x to the negative 2nd would be the same as 1 over x squared. So I'm going to think of this a little bit differently. I'm just going to think of it as these 3 x's cancel with 3 from the denominator and leave 2 behind. So that's going to become an x squared in the denominator. So let me start there. Let me simplify a little bit what we've done so far. So I have 2 by itself now, because all the x's disappeared and z to the 0 disappeared. I have 2 over 10 x squared y to the negative 2. So there's 2 more things I want to do to simplify this expression. I can cancel the 2 with the 10 just as normal numbers. This becomes 1 over 5. And y to the negative 2, a negative exponent in the denominator, can be rewritten as a positive exponent in the numerator. So my final answer for part D is y squared over 5 times x squared. So there we have it. The answers we found for problem 8 are 2 to the 4n minus 1, negative 5 times x to the 11 times y to the 5th, b to the 6th over 25a squared times c to the 8th, and y squared over 5x squared.